Hey guys, my name is Shomo Sharkar and I am a first year Electronics and Communication Engineering student at the Institute of Engineering and Management. In this video, I'll be demonstrating a small simulation project on amplitude modulation and demodulation using MATLAB. We know amplitude modulation or AM is one of the most basic and important methods of sending information using electrical signals. Let's see how it works in practice. In amplitude modulation, we combine two signals, a message signal which carries the information such as voice or music and a carrier signal, which is a high-frequency sine wave used to transmit that information over long distances. The main idea is that the amplitude of the carrier changes according to the message. That's what actually carries our data through the air in AM radio or other analog systems. So let's go ahead and look at the MATLAB script for this project. So as you can already see, I have already written the code. If you want to copy it, you can copy it right now. First, I clear the workspace and set the basic parameters, which is 10,000 Hz. The sampling frequency is 10,000 Hz and the time vector goes from 0 to 0.01 seconds. The messaging frequency is 1000 Hz, as you can see here. And one more thing, if you hear some background noises, ignore them, as it's Diwali and people are bursting crackers. Nothing we can do about that. Let's move ahead. The message frequency is 100 Hz and the carrier frequency is 1000 Hz. Both have amplitude 1, as you can see right here. These values are chosen so the difference between the slow message and the fast carrier is easier to see on the graph. Next, we create two signals. The red line is the message and the blue line is the carrier. Now we look at the code. Here is the demodulation block and here is the comment instant to use demodulation block. When you tune an AM radio, each station uses a different carrier frequency. The sound we hear is the low frequency message, and thus transmitter combines it with the high frequency carrier using exactly this type of modulation. By looking at the graph, which I'll show you in a minute. Okay, let's show you right now. Now you not understand. Let's run this section. Look, we have recovered this graph which is demodulated. This graph is interpreted to display the signals to us, the receivers. By looking at this graph, we can see that the amplitude of the carrier rises and falls in the same pattern as the message. This shows successful amplitude modulation. Now we'll recover the original message from the modulated signal. But unfortunately, MATLAB Online doesn't include the built-in amdemod function, so I used a simple envelope detector made only with base MATLAB. Look here. Look. This process first takes the absolute value of the modulated signal, which rectifies it and then passes it through a moving average low-pass filter. This removes the frequency components which are high in frequency and leaves behind the slowly changing envelope, which is our message. Let's see. Now let's go ahead and run this. As you can see, we have in real the communication systems, the same principle is used here. Microphones convert voice into an electrical signal, which is our message. Transmitters modulate it onto a high frequency carrier so it can travel long distances, which is beyond the scope of this project. Although modern systems often use frequency or digital modulation, AM remains a key starting point for understanding how all wireless communication works. To summarize in this project, I generated a message and carrier signal using the code which I have written here. If you want to copy it, you can still go ahead, take a screenshot, put it in the screenshot to text softwares and copy it. Thank you for watching my MATLAB project on amplitude modulation and demodulation. I hope you have a great day ahead.